Alright guys, so we're talking about right triangle trig. So I have the word up there, SOHCAHTOA, the acronym. It's actually, you guys remember that? Do you remember what it means? Where did you learn it? Do you remember? It was in geometry class. It was in geometry, which was what, two years ago? So it's SOHCAHTOA. So it has to deal with your trig. And so back in geometry, you learned just these three, right? Sine, cosine, and tangent. So we gave you the acronym SOHCAHTOA. And the reason for the acronym is just so you can help remember what's what. So the S in SOHCAHTOA stands for sine. And then O stands for opposite. And H, of course, stands for hypotenuse. So what kind of triangle has a hypotenuse? There's only one. A right triangle. Okay? So if we have a right triangle, obviously then my hypotenuse is always across the right angle, right? So there's my hypotenuse. And then sine is the opposite over the hypotenuse. So the thing is this. Which one's which? How do you know which one's opposite? How do you know which one's... By the way, what does the A stand for? Adjacent. What does adjacent mean? Does anybody know? It just means next to, right? So opposite means across and adjacent means next to it, okay? So how do you know which one's opposite and how do you know which one's adjacent? Good. You have to have a reference angle. You have to have a reference angle. So we call that angle, does anybody know? Surprise, surprise. Theta. We call it theta. So according to where theta is, that determines which one's opposite, which one's adjacent. So this triangle that I just drew, if this is theta, what does that make this one over here? That makes this one my opposite. Therefore, the one at the bottom is now my adjacent. Can they move? Yeah, if my theta moves, right? If my theta comes up to the top here, well, now this one's adjacent and this one's opposite, right? So it's all in reference to where your theta is. So real quick, let's just write down our rules. We kind of already know them. Sine, we said, was opposite over hypotenuse. Cosine is what? Adjacent over hypotenuse. And tangent is what? Opposite over adjacent. Pretend that says adjacent, okay? Alright, so here's the thing. Now I introduced three new trig functions to you. Cosecant and secant and cotangent. Now I'm not going to give you another acronym, okay? Because here's the rule. You already know what cosecant and secant are. What are they? They're just a reciprocal of sine and cosine. So good. So if sine was opposite over hypotenuse, then cosecant is what, guys? Hypotenuse over opposite. Secant is the reciprocal of cosine. So therefore secant is what? Hypotenuse over adjacent. And finally, cotangent was the reciprocal of tangent, is the adjacent over opposite. So I actually know the rules for all 6 of my trig functions. Okay, so it's just SOHCAHTOA, and then of course it's just the reciprocal of all of those based on that. And again, this is all of these opposites and hypotenuse. The only thing that doesn't move is my hypotenuse, right? It's always across the 90. But the opposite and the adjacent are basically in reference to where theta is, correct? Any questions? Everybody go with that? Right? Not new. We good? Can I go? Alright, let's try and use this, okay? Very simple. Let's try and use it. So I'm going to give you a right triangle. Give you a right triangle. This is a 3, 4, 5 right triangle. This is a 3, 4, 5 right triangle. So I call it that, obviously, because the side lengths are what? 3, 4, and 5. Now it's special in the fact that I can multiply the side lengths by 2 or 3 or 5 or 10 or a million, and it'll still stay the same way. Like I can, instead of this being a 3, 4, 5, I can make it a 6, 8, 10. And it's still a Pythagorean, it's still a right triangle, right? Or I can make it a 9, 12, 15. Does everybody see how that works? Okay, so sometimes if you see that, then you're kind of, it gives you an advantage. So here's my theta. Here's my theta, which makes this 3 my what? And makes the 4 my what? And then, of course, my 5 is always my hypotenuse. Okay? So all I'm asking you to do is, well, based on this triangle, tell me what sine, cosine, tangent, cosecant, secant, and cotangent are. So according to my rule, sine is what again? Which is 3 over 5. That's simple. Okay? Cosine is what? Adjacent over hypotenuse, which in our case is what? 4 over 5. Tangent is what? Opposite over adjacent, which in our case is 3 over 4. And then, of course, for cosecant, secant, and cotangent, all I really have to do is flip them. So cosecant, as everybody agree, is going to be hypotenuse over opposite, which is 5 over 3. Secant is going to be hypotenuse over adjacent, which is 5 over 4. And cotangent is adjacent over opposite, which is 4 over 3. It's that simple, okay? So if you know the side lengths of a right triangle, you basically can figure out any, and you know where theta is. That's the important thing. You got to know where theta is. There has to be an established theta. You can't just say, I can't just not tell you theta and tell you to find me all these things, because it's sine of an angle. Remember that. Anytime you're taking a trig function, it's of an angle. So you have to understand what angle you're talking about. We good? Okay? So, I give you this triangle now. What's the thing here, though? I don't have that hypotenuse. Is that trouble? No. Because it's still a right triangle, which means what? How? It's a right triangle, guys. So right triangles always have to follow what rule? Pythagorean theorem, the a squared plus b squared equals c squared. So if you don't know two of them, if you don't know one of them, you can figure out the other two, right? Just by using a squared plus b squared equals c squared. Or, you guys notice anything about this triangle? It's a 3, 4, 5. How do you know? This is 6. This is 8. So technically that's my 3. That's my 4. Which makes this is going to be what? 10. Okay? Say I didn't know that. Say I didn't know that. Fine. I can use my Pythagorean theorem. 6 squared plus 8 squared equals c squared. So 36 plus 64 equals c squared. 100 equals c squared. So therefore c is equal to 10. So either way, you get the same answer. You can either notice the patterns or you don't. And not all of them have patterns. Sometimes they're just random right triangles. So you're just going to have to use your Pythagorean theorem. Okay? So now that I know all the sides, can you find me the sine, cosine, tangent, cosecant, secant, and cotangent? All right, do it. I'll give you a minute. All right. So here's my theta at the top of the triangle. So then what's my sine going to be? Opposite over hypotenuse, which is 8 over 10. That's my final answer? Why not? Always. If you can, always reduce this. This is going to reduce to what? Cosine. Adjacent over hypotenuse, which is in this case, so 6 over 10, which of course is 3 over 5. Tangent starts off as 8 over 6, which does reduce to 4 over 3. And then, of course, cosecant, secant, and cotangent are just simply the what? The reciprocals of those. So cosecant is going to be what? 5 over 4. Secant is 5 over 3. And cotangent is? I do want you to be careful, guys. I am not always going to set it up like this, okay? So don't just assume that this one's the reciprocal of this one, okay? Learn them. Cosecant is reciprocal of sine, okay? So if I throw them out of order, I don't want you to feel lost. You understand what I'm saying? Okay, so just understand the rules. So, I have a question. First of all, y'all guys understand this? Simple stuff, right? I have a question. If I make this my theta, this bottom angle my theta, are my answers the same? No. Why not? Because my opposite and my adjacent switch, right? My opposite in this case would be 6, and my adjacent would be 8. Do you guys understand that? Any questions? All right, let's make it harder, yeah? Just joking. All right, so here we go. So here, in this case, I tell you find the values of sine of 45 and cosine of 45. So this obviously we're dealing with right triangles, okay? Obviously we're dealing with right triangles. And I just tell you sine of 45 and cosine of 45. So what do you think that 45 represents? My theta. So I'm telling you my theta is 45 degrees, correct? So guys, what do y'all remember about triangles from geometry? All their angles have to add up to what? Exactly 180. So guys, this is 90. This is 45. What does this one have to be? Has to be. Is there anything special about this? Good. It's called a special right triangle. It's actually called a what, Madeline? It's a 45, 45, 90. It's called a 45, 45, 90 special right triangle. So, does anybody remember the special rules to it? Okay, so if you know it's a 45, 45, 90, then it has to follow a pattern. Meaning this, the legs of the triangle, of the right triangle, are always the same. I don't care what they are, they're always going to be the same length though. So if you know one, you know the other. Simple as that, right? And then the hypotenuse is always going to be however long your leg is times the square root of 2. So the hypotenuse is always that times the square root of 2. So the fact that you know that it is a special right triangle, meaning it's a 45, 45, 90, just that alone helps you. All I really have to give you is one bit of information. For instance, if I tell you this is 4, well, how long is this one? 4. And how long is this one? 4 square root of 2. Simple as that. If I tell you this one's 8, how long is this one? And how long is this? 8 square root of 2. What if I tell you this is 10 square root of 2? So how long is this? 10 and... Does everybody get that? It's that simple. Now where it gets difficult, it's let me kind of side note you over here. Say I give you it's a 45, 45, 90. By the way, I don't have to label both. If I just tell you one's 45, the other one has to be 45, right? So what if I tell you this is just, I don't know, 6? So that's where people get confused because they're like, where's my square root of 2? There's supposed to be a square root of 2 there, right? Yes, there is. It's just in the number. So here's what you do. You say, look, I know that 6 has to be whatever square root of 2, right? Solve for the whatever. So you would divide by, does everybody see you would divide by square root of 2? So x would be 6 over square root of 2. Does anybody see a problem with that? So it would be what? So how long is this? And it works. Does that make sense? 6 divided by 2 becomes 3. So you see how whatever this is, whether it, bless you, whether it has your radical or not, it still has to follow the rules. Does that make sense? Okay? Even if I was mean and I said, fine, actually this is 6 square root of 5, you would do the exact same thing. Divide by square root of 2, fix it, do what you got to do. Algebra. Okay? Alright, so anyways, that was side note. In this case, I don't tell you anything that it's except that it's a 45, 45, 90. Okay? I didn't even give you side lengths. But you know that whatever it is has to follow this pattern, right? So, can you tell me the sign then? It would be x over x square root of 2. Now, notice anything? Excuse me. The x's will what? So I'll be left with what? If this cancels, there's got to be something up there. So it would be 1 over square root of 2. Notice anything? So then fix it. How? Do I have to put the 1? So it's just going to be square root of 2 over 2. Okay? What about cosine? Can you tell me the cosine? So it would be what? So wouldn't it be the same? Because aren't my adjacent and my opposite the same length? So then, do y'all notice anything? It's going to be what? You guys notice something? Take a look at this again. Take a look at this again. 45 was right here. Basically, what I'm telling you is this. Okay. Basically, what I'm telling you is that, remember, guys, I told you at this circle, it's basically full of what? Right triangles. So, guys, if this was 45, because that's the angle that was created, what was this one? So this was a special right triangle. Right? These are all of them are special right triangles. There's one here on the other side. What angle is this? 45. They're all there. Do you see them? So they're all special right triangles. So they all follow the same rule. Did you notice the cosine and the sine? Wasn't it exactly what we just came up with? Okay. So, remember, I told you that that circle is nothing but special right triangles, right? They're all right triangles. They're all special right triangles. So my first one was 45, 45, 90. Does anybody remember my other special right triangle? There's two of them. 45, 45, 90, and there's one more. Kinda. It was a... It was a 30, 60, 90. You guys remember that one? The 30, 60, 90. It's a 30, 60, 90. So, it also has a special rule. The rule is this. By the way, do you guys remember in geometry, the whole, like, the smaller the angle, the smaller the side length across from it, right? So, the 30 across from it is going to be the small, we call it the small leg. The 60 across from it is going to be the long leg. And then, of course, across from the 90 is my hypotenuse, right? So, the rule for the 30, 60, 90 is this. The 30, across from the 30, it's always just something, x, okay? Across from the 60, it's going to be x square root of 3. And across the 90, it's going to be 2x, basically twice as long as my short leg, okay? Twice as long as my short leg. So, when I label it, it looks like this. Okay? So, does everybody understand what this means? This means that if I tell you this is 2, if I tell you that my short leg is 2, how long is my hypotenuse? 4. And how long is my long leg? 2 square root of 3. Right? 2 square root of 3. So if I tell you this is 10, how long is this? 5. How long is this? 5 square root of 3. Does everybody see how that works? Right? So if I tell you this is 8 square root of 3, then this is what? 8, and this is what? 16. So do you see how I could also do what I did the last time? I can give you just one bit of information, and you should be able to find out the rest, right? Like, let me make it fun. Okay? So this is my 30, this is my 60, and I'm going to tell you this is 7. Okay? So that's 7. Find the other 2 for me. Do you remember how? So according to this is what? Which part? The long leg, right? It's my long leg. So you're telling me that 7 is equal to x square root of 3. So x is 7 over square root of 3. Fix that. 7 square root of 3 over 3. So you're telling me that this is 7 square root of 3 over 3? And so then how long is my hypotenuse? 14 square root of 3 over 3. See how that works? It's just twice as much. Okay? We normally, actually guys, I don't do this to you all the time, but it does happen, okay? So you just have to know how to tackle it. So if the side that's supposed to have a radical doesn't, you know how to deal with it, right? You just set it equal to what it's supposed to be, and then fix it. Okay? So, according to this picture, I give you a 30, 60, 90. Does everybody see that it is a 30, 60, 90? I tell you this is 1. I tell you this is 2. And then I tell you this is actually square root of 3. So what's the sine of 30? What's the sine of 30? It's opposite over hypotenuse, which in this case is what? 1 over 2. What's the cosine of 30? Cosine is what? It's adjacent over hypotenuse. What's my adjacent? Here's my 30. Square root of 3 over 2. Square root of 3 over 2. Do they look familiar? Here's my 30. What's the cosine? So no, but here's the problem. It's not always going to be special right triangles, right? Like the first ones I gave you, 4, 5, 3, 4, and 5. Those are not special right triangles. Okay. So either way, I'm showing you this because that means you can either use your unit circle if you know it's a special right triangle, or you can just use the same rules. It doesn't matter. Any questions? Can y'all tell me something about this triangle? This is my little geometry test. See if you pass geometry. So if this is 1, how long is this one? Which means the whole side is what? Which means this side is what? Which means what kind of triangle was it? Equal what? Equilateral triangle. No, more specifically, it was also, let's see how smart you really are. This one's 30, so what makes this one? Which means the whole one is what? Which means this one was what? So it was also equiangular. Remember that? So, equilateral and first of all, equilaterals are always equiangular. They're the same thing. Is it a what? Actually, very good. This one would be considered an isosceles right triangle. Why? Because 2 of the sides are the same. Very good. You get an A. You get an A for today if I was grading you. Ready? All right, we're almost done. It's the same thing. Don't worry about that one. Okay. Go to your unit circles. Go to your unit circles. Okay? On the back of your unit circles, we have these. These are called trig identities. Now, some of them you already know. Like, for instance, you already know that sine is the inverse of cosecant, or that cosecant is the inverse of sine, and vice versa, right? So you already know these. You have something called your quotient identities. Did you guys know that tangent is sine over cosine? It makes sense because that would be y over x. Therefore, cotangent is what? X over y, or cosine over sine, right? So here's the thing. You kind of already figured those out. Well, we've kind of already figured them out. Let's see if I can use them. Okay? Let's see if I can use them. So I have a question here. The question is this. Find sine if cosecant is the square root of 13 over 2. Find sine if cosecant is the square root of 13 over 2. Well, what do you know? What is their relationship? Cosecant is the reciprocal of sine. Does everybody agree with that? So then if I know one, I know the other. Right? So then if cosecant was the square root of 13 over 2, what's sine? Is that my final answer? No. Fix it. Can I reduce? Nope. So that's my final answer. That's easy, right? So my point is to tell you guys, if you know one, you know the other, right? If you know those rules, you basically can figure out anything you need. You can figure out anything you need. We good with that one? Questions? Okay. Find tangent. Find tangent for me if sine is 3 over 5 and cosine is 4 over 5. So find tangent if sine is 3 over 5 and cosine is 4 over 5. Well, according to your quotient identity, tangent is what? What's the rule? So same thing, right? Tangent is sine over cosine. So if I know sine over cosine, so basically tangent is what? Good. So when you have a fraction divided by a fraction, what do? So instead of dividing, you're going to take the normal top and you're going to multiply by the reciprocal of the denominator, so it'll be 5 over 5's will cancel, so I'm just left with. So there's my tangent. Okay? So again, if you know the rules, which I'm not asking you to memorize them, I gave you a paper with them on it. Okay? You can figure out anything you need. All right, last one. Last one. Well, you're not dead yet. There you go. So last one. Find cosine and tangent if sine is 0.6. So it seems like I'm trying to trick you. It seems like I'm not giving you a lot of information. But guys, you're smart. Don't care what your parents say. 0.6 is what? Can you tell me 0.6 some other way? Does everybody agree that 0.6 is 6 out of 10? Why does putting it in a fraction help? Because sine is opposite over hypotenuse, right? So basically, I just told you that this is opposite and this is hypotenuse. So essentially, do you see I'm building a triangle where I can call this theta. I know my hypotenuse is 10. I know my opposite is 6. And therefore, I could actually figure out the other one. It's what? What did you notice? It's a 3, 4, 5. Okay, I'll send you in a second. So this is a 3, 4. So everybody see how I did that, right? Yeah. What if I didn't know this was a 3, 4, 5? Just Pythagorean theorem, right? So simple as that. So guys, now that I know these, could I figure out anything? Yeah, because I know the rules. If I need cosine, that's adjacent over hypotenuse, correct? Which is what? 8 over 10, which is 4/5. So that's cosine. And then finally, tangent, according to my rules, is what? Opposite over adjacent, which is 6 over 8, which is 3/4. And that's my tangent. So guys, even though feels like I'm not giving you enough, I'm giving you very little information, I'm giving you everything you need. Okay? So some students are like, yeah, sir, but 0.6 is easy because I can change 0.6 to 6 over 10. Guys, what if I give you something like this? What if I told you it was 0.23? I don't know. Can I change that to a fraction? 23 over 100. So then my opposite, or if I told you this was sine or cosine, I'd say, well, one side's 23, the other one's 100. Simple as that. You can change any decimal to a fraction, right? Any questions? So, SOHCAHTOA still applies, but now we have those new cosecant, secant, and cotangent, but those are simply just reciprocals, right? I have two special right triangles. What are they? 45, 45, 90. And what's so special about that one? The legs are the same. Hypotenuse is always x times square root of 2. And then I have a 30, 60, 90. What's so special about that one? The short is x, the long is x square root of 3, and then the hypotenuse is always 2x, okay? So if you find those special things, you're there. Any questions about right triangle trig? Fantastic. Let's finish this.